Hello, and welcome to Compound Interest. My name is Tuesday Johnson. Here's an introduction to concept with applications. Let's look at our compound interest formula. The future value, FV, of an investment of PV dollars earning interest at an annual rate of R compounded M times per year for T years is given by the formula FV equals PV, and then in parentheses 1 plus R over M to the power of MT. Now I use parentheses here for my exponent, even though my TA84 calculator doesn't need it, and some other online calculators don't need it either, but many calculators still require you to use these parentheses, so I like to show them that way and try to use them that way in my examples to help you out a bit. If you treat your interest as I equals R over M, and your compounding periods as N equals M times T first, we'll have a simpler formula, but it's the exact same thing, right? I just replaced R over M with I replaced MT with N. So this is the interest rate that has been adjusted for the compounding periods, and this is the total number of times. So if it's monthly for so many years, we'd multiply the number of months by the number of monthly, or quarterly. My goodness, M got me all confused there. Monthly or quarterly times the number of years. Let's look at some examples. But first, why is compounding better than simple interest? Well, if we start with $100 at 5% simple interest annually, and we start with $100 at 5% interest compounded annually, after the first year, you have the same amount of both. After the second year, you've only made an extra quarter over here in compound interest. What's the big deal? After the third year, I'm up 76 cents. I still can't buy anything from a vending machine except maybe a pack of gum. But if we keep doing this, compound interest is in it for the long haul, right? It'll be there for you in the end. After 30 years, we're more than 4 times what we started with. Whereas with simple interest, we're only 2.5 times as much as we started with. So in the long haul, compound interest is the way to go, and that's why it's a big brain account. All right, let's look at a savings account example. Suppose the First Bank of Johnson was offering a savings account at 2.15% annual interest, compounded quarterly. Find the future value of a $1,750 deposit after 8 years. What is the total interest paid over the time of the investment? Start by identifying our variables. As we're reading through here, first thing we come to is R equals 2.15%, which is 0.0215. Quarterly. How many quarters are there in a whole? There are 4. So our M value is 4. A deposit, so our present value of 1,750, and our time is 8 years. We want to find the future value, but we also want to find the total interest. Let's take a look. So first we're going to substitute FV into our formula, right? FV equals PV, parentheses 1 plus R over M to the power of M times T. All right, so here's what I was talking about. 8 years, quarterly. So it happens 4 times every year for 8 years. So my exponent's going to be 32 times because the compounding is going to happen a total of 32 times. We just pop that into the calculator exactly as you see it typed there, and we'll find $2,077.48. But this problem started with words, so let's finish it there. Our interpretation says the future value will be $2,077.48. Notice I included units, the dollar sign, with a total interest paid of $327.48. How do we get interest? Future value minus present value equals interest. Always future value minus present value equals interest. Let's look at another one. Money from the grants. Jeremiah will receive $20,000 when he turns 18. Determine how much his grandparents deposited when he was born to start the account. If it has been earning 3.6% interest annually, compounded monthly since the date of his birth. Let's identify some variables here. Will receive, so that's in the future, right? He will receive it in the future, $20,000. 3.6% interest, 0.036. 3.6% interest annually, that just tells us our interest rate, but now this tells us compounded monthly. How many months in a year? There are 12 months in a year. Since the date of his birth. Well, so we know the time From the date of his birth till he turns 18, I'm pretty sure that's 18 years. We need to find the present value. How much did they deposit? Well, we'll substitute and solve. First of all, we substitute future value equals present value times 1 plus 0.036 divided by 12 to the power of 12 times 18. Okay. Now, we want to get PV by itself, so we're going to divide by this big giant piece. All right, 20,000 divided by this big giant piece. You could put this in the calculator exactly as it's written. You don't have to do it piecemeal anymore. Calculators are awesome these days. And it comes out to be $10,471.97. So that means Jeremiah's grandparents started the account on the day he was born with $10,471.97, which is the weirdest total to ever start with. And Jeremiah's my grandson, and he doesn't have that money. But I love him anyway. All right, so how long will it take? Currently, Julio has $3,000 in an account that earns 3.8% annual interest compounded monthly. How long until the account has $4,000 in it? Let's identify our variables. Currently, so presently, PV is 3,000. 3.8% is 0.038. Monthly, how many months in a year? 12. I want it in the future to have $4,000, and I have no idea what the time is. So let's substitute. We have a PV. Oh, no, we don't. We have a FV. We have a PV, 1 plus R over M to the MT. And first step, we're going to divide by 3,000. But once we get here, how do we get that exponent out? And how do we get that t out of the exponent? My goodness, put the words in the right order. How do we get that t out of the exponent? Well, we switch to logarithmic form, right? 12t is the power, that's all a logarithm is, that I raise 1 plus 0.038 over 12 to in order to get 4/3. Notice I divided 4,000 by 3,000 to get 4/3. All I did was rewrite this exponential equation in logarithmic form. Now in logarithmic form, we can solve this, whether you use the change of base formula or you have a log base application on your calculator. You could find this value as 90.99. But remember, that's 12t. It's not going to take us 90 years to get $4,000 in it. It's going to take us 90 months, almost 91 months. And if we divide by 12, get t by itself, that's 7.6 years. Our interpretation, it will take 7.6 years, so I don't know, about end of July, for Julio to have 7 years and then the end of July, for Julio to have $4,000 in the account if he leaves it alone, right? You don't add to it, you don't take away from it, and the interest rate doesn't change. That's it for compound interest. I really appreciate you watching. Have a great day.